Okay, first
Okay, let's
first
get
thing,
into it.
I want to start with this, okay? Because I remember myself being in high school applying for astrophysics, and this during the whole process, I was thinking astrophysics is really cool. Also, I have no clue what you do in astrophysics. Like, if you would have asked me at the time, like, name like one thing that you study, I could have said like stars,
Mm-hmm.
but like nothing beyond that. I mean, like I didn't know what a star really was back then.
Valid.
It's a ball of gas, but what does that really mean, right? How do they work? I don't know. I didn't really know anything about astrophysics. So this is for all the people that were like me. What do you learn in an astrophysics course? So here's the outline. And I think it's such a beautiful story that it tells. And same thing goes for what's that course? I think it's no, it was linear algebra. Linear algebra, the course that I took last semester with Dr. Wolski, actually, he was on the podcast twice. The story that course told was beautiful because we started off just looking at like determinants and diagonalizability briefly. And then we went back to starting with vector fields and then going all through linear combinations, linear transformations, all these things, and then ending with diagonalizability and whatever that form, the canonical form and stuff like that. It was such a beautiful story that it told. And the same thing is happening with our astrophysics course. And here's what we're doing. So essentially, in astrophysics, you study things that happen in space. There are a lot of things that do happen. And so it's a pretty broad situation that you have to study. So you kind of have to pick and choose the things that you group together. And so the first thing we studied this year were the equations of state. Now, this constitutes like hydrostatic equilibrium. For example, if you have like a balloon underwater, is it going to rise? Is it going to fall? If you increase the pressure differential, is it going to rise faster? What happens? What do the conditions need to be for the ball to just stay static in space?
Mm-hmm.
You know, you have to deal with, what's the pressure at the top versus the pressure at the bottom. If they're different, then there's going to be a force and things are going to move around. We talk about a lot of different types of pressure because in space, these objects that we call stars are naturally occurring objects. And we just try to explain how they occur and what are their properties. Turns out that, it's not just one thing. There are different types of stars depending on their initial conditions, and the way they evolve also changes depending on how big they were initially, how massive they were initially. Different types of pressures become important in different situations, and we're actually going to talk more about that this episode. So yeah, we start off by talking about just clumps of gases, how to describe the equations that determine the motion of the gas in space.
Also, like a clean advantage, I think, of like astronomy is that, well, at the end of the day, you're dealing with things in space. So it's not like on Earth where there are multiple things, multiple factors. Now, that's not like you don't have to take factors into consideration in space, but it's much more like you're in an isolated system, now deal with something. Mm-hmm. And I just like that, especially like as you were saying, like, you're kind of picturing things now, first of all, also like on a much bigger scale, because like your whole intuition about distances and sizes is kind of just completely skewed, right? The moment you get into it, because like we see some stars and some clouds that are like 10 times the mass of the sun, like a cloud, for example. And like, what does that really mean? Like there are very many different parts of, how complicated it can get. And I think that's what's the beauty of just understanding and kind of appreciating what it is. Because at the end of the day, like as you said, I mean, it's a naturally occurring effect it'll happen. And the beautiful thing about astrophysics, I mean, real all physics, but mainly in this thing, like that, it's kind of a thing that takes place regardless of us being there. Like the human race has played like a microscope, like it's a microscopic thing in the age of the universe, and no matter where we are, if we are alive or if we're dead, like the universe will exist. The physics of that will continue existing, and like it's just so beautiful to think about that they have such large, just what am I trying to say? Like like I'm just trying to say like they have very unimaginable sizes, unimaginable quantities of things that at the end of the day, the only thing you can do with it is put it on paper and try to understand it, because it's happening there whether or not you see it. But if you want to understand it, the only way to really do that is do it on paper, because of the real vastness of what we're really studying, right?